Although Mars is nearly geologically dead, it's not completely boring. Close inspection through rovers and orbiters has shown that it has weather. It has a mild hydrological cycle. There clearly has been volcanism. Olympus Mons is a prodigious volcano, the largest in the solar system. And the rovers and objects we left on the surface have shown that there are dust devils and widespread dust storms on occasion. Starting in the 1970s, orbiters showed features that to any geologist on Earth speak to water. Dendritic river canals, erosion forms that are typical of sedimentation, all of these features together indicate water has flowed sometime on the surface of Mars. But it's indirect morphological evidence, and it was not always sufficient to convince planetary scientists that Mars is or even has been a wet planet. The idea is, as with Venus, that Mars was more habitable in the past, particularly 2 to 3 billion years ago. But now, as revealed by the first landers, starting in the mid-1970s, the surface is arid and uninteresting looking, just a sea of rocks and dust, more arid even than the worst and most barren deserts of the Earth. However, this barren surface does not preclude there being liquid water under the surface, where it might be kept liquid by a combination of pressure from the above rocks and radioactive heating from below. As the orbiters and imaging level improved down to meter-level resolution, the sea of morphological features indicating shallow oceans or rivers or water runoff accumulated over a series of decades. People have tried to visualize what Mars might have been like with shallow seas over much of its surface. Although the evidence is indirect for an earlier, wetter Mars, it's fairly compelling taken together. In particular cases, water even reaches the surface, and we now have evidence of this. There are Martian gullies where some of the features are archetypal of what might be left by liquid water running down a hillside. The speculation is that these are zones where a subsurface aquifer, that in general is 30 to 100 meters underground, reaches an escarpment and the water can bubble out and through and then down a hillside. Striking evidence of this happens from orbiters. In pictures taken less than 4 years apart, an escarpment shows a new feature that appears. Geologists have tried to simulate this morphology by a situation where dust or dirt runs down a hillside, but they can't do it. A liquid is required. In this case, a 200-meter long channel down a hillside was carved by the equivalent of 10 swimming pools worth of water erupting momentarily out of the hillside. This water carves a channel and then almost immediately evaporates. If you placed a cup of water on the Martian surface, the water would boil and evaporate in less than a second. Recent imaging has cemented the idea that Mars has a lot of water. Radar imaging of the mid-latitudes reveals subsurface glaciers. They're invisible to standard imaging because the ice is covered by tens of meters of rocks and so looks like an interesting landscape. But the radar reveals the water underneath, and the inventory of this water is truly impressive. Taken as a whole, Mars has enough subsurface glaciers that if they were all melted, they would cover the entire planet with 20 centimeters of water. So while we think Mars is dry and arid, it need not always have been the case. A few years ago, an exciting new ingredient was put on the table in considering an active and potentially living Mars: methane. On the Earth, methane is a potent greenhouse gas. It's also a signature of biological activity. A significant fraction of the methane on the Earth is produced by ruminating beasts like cows. Cow farts, if you like. So methane is a biomarker. Methane was discovered on Mars, coming off the surface at a very small level, a few parts in a billion. Now that's thousands of times less than the concentration of methane on the Earth, but it was exciting enough, since it is a biomarker, to lead people to speculate that microbes were metabolizing methane under the Martian surface and that methane was eking out into space. Even more exciting, the methane is patchy in its distribution on Mars, and images taken several years apart show that it's time variable. Surely this is evidence of biology. Methane is unstable. So much ultraviolet radiation reaches Mars that the methane we see should be destroyed by light in a few hundred years, which means that it must be replenished on the same timescale. To people thinking that Mars might be biologically active under the surface, this was yet another piece of evidence in that direction. Unfortunately, this is not convincing evidence. After several years of discussion, geologists and geochemists have come up with other mechanisms whereby a few parts in a billion of methane can be produced without any biology involved. In other words, this could be pure geochemistry. So Martian methane is proving tantalizing and does not strongly indicate life on Mars. Mars is dry and arid as we speak. If you put a cup of water on the surface, it would boil and evaporate almost instantly. But there's strong indirect evidence that Mars was warmer and wetter in the past, and may even have had shallow seas. Even now, the inventory of subsurface ice in glaciers in the mid-latitudes would form the equivalent of 20 centimeters of water all around the planet. Mars also has a tantalizing amount of methane, which is considered a biomarker. But in this case, the level is so small that it could result from purely geological reactions.